Basically, the crux of that magnetic effect of current is what happened was, suppose there is a current carrying conductor like this, some current carrying conductor. Current is flowing in upward direction. All right. Now, if you take any element, suppose of length L, tell me what is total charge in this? What is total charge in this? Any element of current carrying conductor, what is total charge in this? Tell me, bacho. Any static charge is there in it, by the way? No, right? All the charges are moving. So whatever amount of current is entering here, the same amount of current is leaving here. So we can say that the total static charge inside this region is zero. Do you guys agree on it? अबे हाँ ना तो बोलो. This is first basic point. Whenever current flows through a conductor, if you take any cross section or any small length of it, the total static charge inside it is zero. So logically, if I keep one charge of Q at a separation D from this, according to the electrostatic force, what is the formula of electrostatic force? K Q1 Q2 by R square is force. But this force is assumed to be zero, and we also practically see that there is no force between these two. By the way, this charge was at rest. All right. So we can understand that whenever we keep a charge at rest near the current carrying conductor, this charge will experience no force at all. If there is no force, this is charge, and here there is no static charge. So no force means electrostatic force doesn't act. And electrostatic force is zero. All right. But surprisingly, when they did this in the following manner, they took a current carrying conductor at a distance of the current carrying conductor. They have kept a charge, but this time the charge was moving. This time the charge was moving with some v velocity. So surprisingly, they saw that same charge when was at rest near the same current carrying conductor, it was experiencing no force. But when it was given some velocity, or when it was moving near the current carrying conductor, suddenly it started experiencing some force and its trajectory changed. If its trajectory is changing, that means there must be some force acting on it. So some force is there. And we are sure that this is not electrostatic force. This force is not electrostatic force, because if it was electrostatic force, it would act here also. Even though when charge was at rest, electrostatic force will act. Even though when charge is moving, electrostatic force will act. ऐसा तो हमने कभी नहीं पढ़ा electrostatic force will only act when body is moving. It will act on the body charges also. So if it is not acting here and if it is acting here, this force was not electrostatic force for sure. Because if it was acting in the second case, it should also act in first case. But in first case, when charge was at rest near the current carrying conductor, no force was acting. But in second case, the same charge, when it was given some velocity near the same current carrying conductor, it started moving. It started experiencing some force. तो फिर साइंटिस्ट पागल हो गए. They thought, what is this new kind of force? What is this new kind of force? Then suddenly one day, like while thinking on it, while thinking on the force experienced by a moving charge near the conductor, if you have remembered, there is a scientist called as Hans Christian Oersted. He accidentally saw that a a compass kept near the current carrying conductor is showing deflection. Is showing deflection. Then he thought that compass is defective. My compass is defective. He bought different compasses he saw. But anyway, he saw that compass or any bar magnet or any natural magnet, if it is kept near a current carrying conductor, they are orienting themselves, or they are moving, or the needle of the compass is getting deflected. What do you mean by that? The unknown force which was acting on the moving charge was nothing but what force, bacho? Magnetic force. After doing this experiment, to be very honest, this was not experiment. This was by accident he saw it, and again he did some research on it, and he finally figured out that whenever there is a current carrying conductor, it will generate some magnetic field. And if I keep a moving charge in that magnetic field, it will experience some force. But if the charge is at rest in a magnetic field, it won't experience any force. All these were the conclusions of the experiment which were conducted by Hans Christian Oersted. मैंने जो बोला अभी तक सब समझ आया?
Yes, sir.
Guys,
Yes,
please
sir.
attend the class on time. No, you are coming 10-15 minutes late. Again, you will miss some stuff. Please come on time, bachcho. All of you understood this? All of you understood this?
Yes, sir.
So ultimately, the conclusion was, what is the conclusion? Current carrying conductor generates what? Which field? Magnetic field. Yes or no? अबे हाँ ना तो बोलो. Similarly, if you remember, static charge at rest will generate electric field. Now, to find that electric field, there was a law which was called as Coulomb's law. Electrostatic force is k q1 q2 by r square. Electric field is k q by r square. Whatever that was given by Coulomb's law. So similarly, to find a magnetic field due to any current carrying conductor, there is a law again. Law means what? It is not got any mathematical proof, but yeah, it has been verified number of times experimentally, and that holds true for all the other cases of in the real environment or real life or real physics situation. So that is called as law. लॉ का कोई प्रूफ नहीं होता, बट इट इज यूनिवर्सली ट्रू. इट हैज बीन प्रूव्ड एक्सपेरिमेंटली. समझ आया?
Yes,
So
sir.
that law is called as Biot-Savart's law. What is the use of Biot-Savart's law? Biot-Savart's law enables us to find magnetic field due to a current carrying conductor at any point which is at a distance of d from that current carrying conductor. Now let us proceed on what does law says. ध्यान से सुनना. dB is small elemental magnetic field which is given by mu naught I by dl bar cross r bar by mod r bar ka whole cube. This is Biot-Savart's law. Now half of you already died after seeing this formula. So let me explain it and let me elaborate it. Suppose this is our current carrying conductor, some random shape. Suppose this is our current carrying conductor of current I. All right, understood? Now at a distance, now I am considering a small element dl bar. I'm considering a small element dl bar in this. What is current in this dl bar? I only, because only I current is flowing in this conductor. Because of this small element dl bar, I need to find magnetic field at a point P, which is at a distance of r bar from the dl bar vector. I need to find magnetic field on this point. अरे हाँ ना तो बोलो. What is the direction of dl bar? Direction of dl bar is in the direction of current. This is dl bar. This small vector is dl bar. This one. And what is r bar? R bar is position vector of the point on which I need to find magnetic field from the point due to which I am finding the magnetic field. So R bar is from DL bar to point P. R bar is directed from elemental length DL bar to point P on which I need to find a magnetic field. So in this case, DL bar is like this and R bar is like this. Now tell me what will be the direction of DL bar cross R bar. Tell me what will be the direction of DL bar cross R bar. If you remember cross product, you can use your right hand. DL bar is like this, R bar is in that direction. So DL bar cross R bar means I have to curl my fingers like this. So the magnetic field will be into the plane of the paper or into the plane of the screen.
Right hand thumb rule.
Right hand rule. Yeah, vectors. How what we use? What we use in vectors? A cross B. How to find A cross B? Suppose A bar is this vector and B bar is this vector. How to find A cross B? A cross B will give you the direction. A is black one. This is B. So what is A cross B? A cross B. Understood? So we should know how to use our uh, cross product ka formula and thumb. Otherwise, we won't be able to clearly determine the direction of magnetic field. Anyways, now can this be written as mu naught I dl bar ka magnitude into r bar ka magnitude into sine theta. What is theta? What is theta? Theta is angle between DL bar and R bar because cross product का formula क्या होता है A cross B. What is A cross B? Magnitude of A into magnitude of B into sine of angle between them. Correct or not? You guys understood? Okay. You guys understood?
Yes, sir.
Fine. Divided by mod R bar cube. If you see this mod and this will cancel and we are only left with, so magnitude of magnetic field is mu naught I mod dl bar into sine theta by mod r bar ka whole square. This is magnitude. Direction, how we can find? Dl bar cross r bar. So we know the magnitude of magnetic field and also we know the direction of magnetic field. I hope you guys understood this. Understood this? Sure? 100%? All right. If you want to copy something, you can copy. If you want to take screenshot of something, you can take screenshot of that. Can I scroll down? If you guys understood, if you guys have any doubt in this, please raise your hands and ask me. Okay. So now my intention is to find magnetic field due to a current carrying conductor, some current carrying conductor, which is like this. Suppose this is our current carrying conductor. This is my current carrying conductor. Wait, 1 second, why it is getting stuck? Yeah, suppose this is my current carrying conductor, like this. All right. I need to find magnetic field at any point P, here somewhere. This is our point P due to this current carrying conductor, due to this current carrying conductor. Yes or no? बच्चों आना तो बोलो. The perpendicular distance of the point from the wire is D. What is the distance? D. Understood? अबे आना तो बोलो. Now if I take the ends of the wire and try to join it with the point P on which I need to find magnetic field, it will make an angle theta 1 with the perpendicular and this will make an angle theta 2 with the perpendicular. Yes or no? Yes or no, bachcho? Now magnetic field at point P is given as mu naught I by 4 pi d into sine theta 1 plus sine theta 2. All right. This is the formula. Now derivation of this formula, again it will take 5-10 minutes, which I am omitting now, but that will be definitely covered in your class. It might be done in your class. How many of you already derived this in your class? Raise your hands. Okay, only 8 hands raised. What about others? Okay. Okay, then what do you guys want? Do you want me to derive or should we go with the formula directly? Tell me, guys. Lower your hands. Those who are derived, please.
So you can give the formula for now. Derivation will be done in tomorrow's class anyway.
okay, guys. Okay, fine. Okay, guys. Okay. So this is the formula. What is the formula? Formula says that magnetic field at point P is mu naught I by 4 pi d into sine theta 1 plus sine theta 2. Now let us understand significance of each of the terms in the formula. Mu naught is a constant. Mu naught is later on called as permeability of free space, and its value is 4 pi into 10 power minus 7. You will understand about mu naught later on while studying electromagnetism and magnetostatics and all, but I'm not emphasizing on it. What is I? It is a constant value basically. I is current in the wire. D is what? D is perpendicular distance of the point from the wire. Theta 1 is what? Theta 1 is angle made by one end of the wire with perpendicular. Theta 2 is angle made by wire, sorry, angle made by other end of the wire with perpendicular. Can you see all the terms? Now, if you see very carefully, theta 1 and theta 2 are taken in opposite senses. Are taken in opposite senses. What do you mean by taken in opposite senses? Theta 1 I am measuring in clockwise direction, and theta 2 I am measuring in counterclockwise direction with respect to perpendicular. Can you see that? Bacho, can you see that?
Sir, can you repeat that?
What I am saying is, if you see theta 1 and theta 1 is measured like this in this direction. I mean clockwise direction. So this is our reference point. Perpendicular is our reference point. To reach the line joining one end of the wire and point P, I am moving in clockwise
Sir, but
direction. So
if
theta
you
1 is
go
taken in
opposite
clockwise
direction,
sense, and theta 2 is taken in, well, theta 2
anti-clockwise.
is taken in anti-clockwise
Anti-clockwise.
sense. So basically, theta 1 and theta 2 in this formula are in same direction, are in same senses, or they are in opposite senses.
Opposite.
Opposite senses. So whenever I need to apply this formula, I need to ensure that theta 1 and theta 2 are in opposite senses. कभी तो हाँ या ना बोलो.
Sir, what
बोलो
difference
बेटा.
does it make, sir?
What?
What difference does it make?
That you will understand while deriving the formula.
Okay,
While
sir.
deriving the formula, if you integrate from theta 2 to theta 1, you will get one answer. If you integrate from minus theta 2 to theta 1, you will get one answer.
Okay, sir.
Because if I'll ask you one simple question, what is angle between this vector and this vector? What is angle between these two vectors?
120.
120. But what is angle between these two vectors? 60, right?
60,
Okay.
yeah.
Yeah. So in vectors, the angle between the two vectors also have their own impact on the final answer, because vectors do depend on directions. And magnetic field is a scalar quantity or vector quantity?
Vector.
Magnetic field is scalar quantity or vector quantity?
Vector, vector.
Yeah. So now we are bothered with the formula. Magnetic field due to a wire current carrying I at a distance of d from it is mu naught I by 4 pi d sin theta 1 plus sin theta. Correct? बहुत अच्छा सर, अच्छा लगा. Let me give you one question. You tell me, you can you do that question or not? Very simple question. अच्छा, how to find direction बच्चों? How to find direction of field? How to find direction of field? One is cross product. What is cross product? DL bar cross R bar. Current is moving upwards, so DL bar is upwards. R bar is on right side. So I will move from DL bar to R bar. DL bar to R bar. So my thumb will indicate the direction of magnetic field. So at that point, the magnetic field is into the plane. कैसा है magnetic field? Into the plane. Do you guys understand how to take the cross product? dl bar cross r bar. So magnetic field is into the plane. Understood?
Sir, can you explain that once again?
Current is flowing like this. R bar is here. Correct or not?
Yes, sir.
Then what is direction of dl bar cross r bar? You tell me. dl bar cross r bar. dl bar cross r bar into the plane. Curl your fingers from dl bar to r bar. When I do a bar cross b bar, what I'll do? I'll curl my fingers from a bar to b bar. Then the thumb will give you the direction of resultant vector. बोलो आंटी समझ आया?
Yes, sir.
Okay. Now to make the things थोड़ा सा simpler, I'll also tell you palm rule. अब ये palm rule क्या है सर? सुनना. If thumb represents the direction of current, if thumb represents the direction of current, stretch the fingers of your palm of right hand towards the point on which you need to find magnetic field.
Sir, FBI rule. Force, current,
And this
and
will नहीं वो अलग है.
direction.
So
This
isn't this
is
just right hand thumb rule?
No, palm rule is like FBI rule. You said
no,
it will be.
no beta, no. Whatever I'm saying is different, and what you are pursuing is different. Right hand thumb rule is different. वो फ्लेमिंग्स राइट हैंड रूल फ्लेमिंग्स लेफ्ट हैंड रूल डिफरेंट है. जो मैं बोल रहा हूँ वो पाम रूल है. सुन लो. This is the direction of current. I need to point my other fingers towards the direction of point on which I need to find magnetic field. So the push of the palm will tell you the direction of magnetic field, which is again giving the answer as into the plane or out of the plane.
Out of the plane.
Huh? I'll kill you. अबे into the
So,
plane or out of the plane आ रहा
it's
है?
coming out of the plane. No, it's coming towards us.
What beta? What? What?
Sir, isn't that out of the plane? The palm is going towards out of the plane.
This is out of the plane.
Yeah.
अबे see the plane of your screen, not my hand, not my plane. Plane of the diagram.
Into.
Current is moving upwards. My point is here. So magnetic field is into the plane according to the diagram. Don't see my
Sir,
plane.
I was telling into only.
Okay, so why you are shouting?
No, you are like, you kept your hand on your face, and I thought I'm wrong.
I talked to the person who said out of the plane,
I
not
said
you.
into. Okay.
ठीक है, don't get overexcited in my class. That is palm rule. So suppose I ask you one simple question. This is the direction of current. What is direction of magnetic field at point P? Tell me into the plane or out of the plane. You only will tell. The girl who got overexcited. Who is that?
Sir, Divija.
Yeah, tell me the
Yeah,
answer.
1 second. Can I go to the screen once?
हाँ, जो करना है कर. You tell the direction of magnetic field on point P. Into the plane or out of the plane?
Sir, it is out of the plane.
Yeah. This is out of the
Out
plane.
of the plane.
Current point P out of the plane. Now you
Yeah.
can use either ways. You can use palm rule or you can use vector R cross P, L DL bar cross R bar. Anything will give you same direction. Answer would be same. Chalo. Correct or not? Now my question is very simple. Use the formula and find magnetic field on center of the square loop. This is a square current carrying loop. This is a square current carrying loop. On its center C, I need you to find magnetic field. Current is going like this.
Sir, your screen is lagging.
Oh really? Now?
Yeah, it's
Now
stopped.
is it
When you
lagging?
stopped writing, it's fine. So when you were writing, it like suddenly stopped and then it come fully.
ठीक है, चुप रहे. Square loop of side A. You need to find magnetic field at point C. Now tell me, this point C ka magnetic field will be combination of how many wires?
4.
Do you guys agree? Is it 4 or not? Yes, it is 4. अबे 4 है ना, 1 2 3 4 कर गधेड़ो. Now tell me, what will be the angle made by this with perpendicular?
90.
This is perpendicular, right? The
Okay.
non-dotted one is perpendicular line. What is the angle made by this?
45.
45 and 45 and 45, because it's a square loop. हाँ ना, तो बोलो.
हाँ सर.
अभी बोलो ना. So magnetic field B is mu naught I by 4 pi D. Current is I. What is D in this case? Perpendicular distance of the point from the wire.
A
What is
by
the
2.
perpendicular distance of the point from the wire? A or A by 2?
A by 2.
Into sine theta 1 plus sine theta 2. Into sine theta 1 plus sine theta 2. Now tell me, what is, first of all, theta 1, theta 2 are taken in same sense or opposite sense in the given question?
Opposite.
So our required formula is validated. So I can directly put theta 1 as how much? 45. And theta 2 as
45.
45. So sine theta 1 is sine 45, which is 1 by root 2. And sine theta 2 is
Root.
also 1 by root 2. So B is mu naught I by 2 pi A into 2 by root 2, which is root 2.
Yes sir.
But this is magnetic field due to one wire or all the wires?
One wire.
One wire. This is due to, suppose, wire 1. Now tell me, what will be the direction of magnetic field due to wire 1 on point C? Into the plane or out of the plane?
Into the plane.
All of you can perceive this into the, it as into the plane. Bacho, tell me, correct or not?
Yes, sir.
It will be into the plane. Now tell me, due to wire 2, what is the direction?
Into the plane.
Check properly, into the plane or not? अभी
Yeah.
बोलो, into the plane or
Into the
not?
plane. Into the plane.
Correct. Wire 3,
Out.
चप्पल. Wire 3,
Into the plane.
हाँ.
समझ आया?
सर आपका
Current is
कैमरा
moving like
उल्टा
this.
दिखा रहा है.
What?
Sir, your camera is showing it ulta, sir. That's why.
घर जा. You yourself apply no rule then. You tell me, it will be into the plane or out of the plane?
Out of.
Why, man? If current is
We
flowing like
into
this,
the plane.
my consent point P is here. How you will do DL bar cross R bar, or how we will use palm rule? This is the direction of
Oh,
current.
sir, into.
Again, due to 4 also it is. Check, due to 4 also it is into or out to out. Tell me.
Into.
Into.
Into. आना तो बोलो.
Yes, sir.
So all the 4 wires are having magnetic field in same direction or opposite direction? Same direction.
Same.
And this point is symmetric with respect to all the 4 wires. So final answer will be multiplied with 4
4.
to get net magnetic field. समझ आया कि मर गए?
समझ आया, sir.
Sure? All of you?
Yes, sir.
Okay.
Sir, if there were any of them going like out of the thing, would you cancel
I would
out?
have subtracted it. I would
Oh,
have subtracted it because magnetic field is a vector quantity and it does have sense of direction, right?
okay, sir. Okay.
अब तुमसे बढ़िया सवाल पूछता हूँ, गड़बड़ मत करना, गोली मार दिया जाएगा. This is 30 degrees and this is 60 degrees. This distance is 2 meters. The current is 2 amperes. Find the magnetic field on this point P.
Sir, your screen is frozen.
I will try to turn off my video then. Then the screen will be like properly working maybe.
Yes, sir. Yes, sir.
Hmm. Now tell me, what is magnetic field? Mu naught I by 2 pi. What is the distance?
2.
Distance is 2
2 meters.
into sine theta 1 plus sine theta 2. What is sine theta 1? First of all, theta 1 and theta 2 are taken in same sense or opposite sense? This is our perpendicular, no?
Sir, it's
To measure
frozen.
theta 1, I am going in clockwise direction. To measure theta 2, I am going in opposite direction or anti-clockwise direction. So theta 1 and theta 2 are taken in opposite senses. So you can directly substitute sine 30 plus sine 60. This is the answer. And I is anyways 2. Got it?
Sir, so won't 2 get cancelled?
Obviously, it will get cancelled. Sine 30 is half and sine 60 is root 3 by 2. That calculation
Hmm.
can't you do?
No, no. I told the fan. Okay. Sorry, sir.
It already got cancelled. Sir, she was asking 2 mu naught. That thing.
Yeah, that was my doubt.
You want to cancel this and this.
Hmm.
अच्छा ये 4
Just
पाई होगा ये
asking.
बोल रहे थे. Yeah. Now I'll ask you one more question. Suppose this is my point.
Sir, it's frozen.
This distance is A. क्या हुआ? It is?
Frozen. There's nothing.
यार.
It came now. It came now.
Okay. This distance is A. This is our point P on which I need to find magnetic field. These are perpendicular. This angle is 30 degrees and this angle is, let us say, 30 more degrees. Now you need to tell what is B at point P. Again, formula current is anyways I. If you know I, you can find the direction. Mu naught I by 4 pi d into sine theta 1 plus sine theta 2 is the formula. Tell me what is D in this case?
A.
What is D in this case?
A.
Wrong. D was what in the formula?
Oh,
Any
perpendicular
distance
distance.
or perpendicular distance.
Perpendicular.
So if this is our wire, this is the point. What is the perpendicular distance? Extend the wire
Side.
and draw the dotted line and check the perpendicular distance. Yes or no?
Yes, sir.
Now tell me what is D? A cos 30. D is,
A cos 30.
if you see this right angle triangle, this right angle triangle, what is D? A cos 30. Yes or no? Bolo beta.
Sir.
Understood? Okay. Now next question. What is theta 1? First of all, you should understand the definition of theta 1. Theta 1 is angle made by one of the ends of the wire connected to point P with perpendicular line.
60 degrees.
So theta 1 is taken as,
60.
all of you are understanding how theta 1 is taken as 60? Yes or no? Any
Yes,
doubts
sir.
in this? Please ask me. Any doubts in this? Please ask me, bachcho. No doubts? Okay. Now tell me what is theta 2?
30.
Yeah, most of the thing will go wrong here. Listen to me very carefully. How theta 1 was measured? Clockwise or anti-clockwise? From perpendicular.
Clockwise.
How theta 2 you are telling us 30? Clockwise or anti-clockwise?
Anti-clockwise.
अबे 30 clockwise है कि anti-clockwise है? अंधा है क्या?
Oh,
This 30 degrees is clockwise or anti-clockwise?
clockwise.
But in actual formula, both the angles were in the same sense or in opposite sense.
Opposite.
So theta 2 is 30 or 360 minus 30,
360 minus 30.
which can
330.
also be written as minus 30.
Oh,
समझ आया आइटम?
sir.
मेरे को लगा ही नहीं. Some people got confused. How many of you have doubt in this? Please raise your hands. Okay. चलो, let us go to the original formula. तुम्हें अच्छा लगेगा. देखो, suppose this was our original formula, right? Here theta 1 and theta 2, the formula is sin theta 1 plus sin theta 2, that is correct. Now theta 1 and theta 2 are taken in same sense or in opposite sense? Sense
Opposite.
means same direction or opposite direction. But in this given, that formula is only valid when theta 1 and theta 2 are taken in opposite senses. So while applying that formula, we'll ensure that we'll substitute the values of theta 1 and theta 2, where theta 1 and theta 2 are taken in same sense or opposite sense?
Opposite.
Opposite sense. मुझे लगा ही नहीं तुम्हें आया. Got it?
Got it, got it.
So in the given question, if I am taking theta 1 as 60 degrees in clockwise, then I can't take theta 2 as 30 degrees in same clockwise. I have to take theta 2 in counterclockwise direction. Kupach, ऐसे. This will be 360 minus 30, 330 और minus 30. दोनों में से कुछ भी ले लो, आंसर सेम आएगा. हाँ ना तो बोलो.
I got it now. Thank you, sir.
Okay. I'll do one more question. देखो, थोड़ा और अच्छा. अच्छा, what is direction of magnetic field at point B in this case? Direction बोलो. Direction. What is direction? बच्चों, what is direction of magnetic field at point P? Tell me.
Inside the plane.
Into the plane. Correct or not? Current is moving upwards. You can stretch your fingers towards the required point and check. अभी तुम लोग कंफ्यूज हो गए कि समझ आया?
Got
Understood?
it, sir.
Current is like this. You can shift your fingers toward the direction of the point. The palm will show the direction of field into the plane. Yes or no? ठीक है, बहुत बढ़िया सर. कुछ समझ नहीं आया, कोई बात नहीं. Here I am taking some point P at a distance of L. All right. Suppose this angle is 37 degrees. This angle is 37 degrees. और क्या कर सकते हैं तुम्हारे प्लान निकालने के लिए? Hmm. Yeah. Before going to this question, anyway, I can take any data, but ठीक है. Before going to this question, I'll also like to add one more point. See very carefully. This is I current. This distance is D. I need to find magnetic field at point P. What is the formula? Mu naught I by 4 pi D into sin theta 1 plus sin theta. Correct or not? Suppose this is an infinite wire. कैसा wire है ये? Infinite wire. Suppose this is an infinite wire, then its length will be somewhere here, and its length will be somewhere here. Now tell me what is the value of theta 1 and theta 2? Logically बताओ, what is the value of theta 1 theta 2? This is our perpendicular distance D. Tell me when it will meet. It will meet at infinity. It will also meet at infinity. It will tend to infinity. So this angle will be, and this angle will also be 90. हाँ ना तो बोलो. And they both of them are taken in opposite senses. बेटा हाँ ना तो बोलो.
हाँ सर.
Yes, sir.
So answers will be mu naught I by 4 pi d into sin 90 plus sin 90. Sin 90 plus sin 90 will be 2. So answer will be mu naught I by 2 pi d. This is magnetic field due to infinite current carrying wire. बोलो बच्चों, got it? Got it or not? So basically, if one end of the wire is tending to infinity, the angle theta is taken as 90 degrees. That is my point. I hope you guys understood it. Yes or no? Understood or not? बोलो ना. Understood?
Yes sir.
So now I am doing one thing. I am just saying that this wire is semi-infinite. That means one side is of finite length, but the other side is tending to infinity. I need to find magnetic field at point P. Again, what does formula suggest? Mu naught I by 4 pi d sin theta 1 plus sin theta 2. If I know d theta 1 and theta 2, my job is done. Now tell me what is d. D is L or something else? D is equal to L or something else? अबे बोलो ना. D is equal to L or something else?
Something else.
See what it is.
What
It
is
is the
that?
perpendicular distance, right?
Perpendicular only, so it will be L.
So D is what? L or L sin theta?
L
L.
Got
sin
it?
theta.
You
Yeah.
understood this? Okay.
Yes sir.
Now tell me what is, क्या this is our perpendicular? One end of the wire is making how much angle with perpendicular? 37 or 53? बोलो ना, 37 or 53? अबे if this is 37, this is 90, so this should be
53.
53, right? So one end is making 53 and other end is making
37.
how 37? One end of the wire is this. This is making 53 and other end is making how much? ये infinite length का है ना, so it will meet it at infinity, so this angle will be 90. हाँ ना तो बोलो आंटी. This angle will be
90.
90. ध्यान से देखो. This angle will be
90. Sir, your screen is freezing in between, because of which I can't understand figure. बाद में जब आप बनाते तब समझ में आता है फिर से. The screen is freezing a lot in between.
What I can do? I'm a poor guy. I don't have as good internet connection as you. All of you, please collect and donate some money to me. अब चुप हो गए. Now everyone will say, nice screen, sir. Nice timing. Nice internet connection. Anyways, ध्यान से देखो, please. You understood what is 53 and what is 37 again, or do you want me to tell again? The angle made by one end of the wire with the perpendicular is 53? Yes or no? अब yes or no तो बोलो तुम.
Yes, sir.
The angle made by other end of the wire will be how much? It will meet the other end at infinity because the length is infinity. So the other end will make how much angle? 90 degrees. Now 53 and 90 are taken in same sense or opposite sense? Bolo? Same sense or opposite sense?
Opposite.
Angles are opposite sense, right? Same sense, right? अबे opposite कैसे? This is also going like this. This is also going like this. So this is as per our formula or the opposite to our formula. In our formula, both were taken in same sense or opposite senses. गधेड़ों बार बार भूल जाते हो तुम. In our formula, both were taken in same sense or opposite sense. In our formula, both were taken in same sense or opposite sense. You tell me.
Opposite.
Then this formula is valid. But here they are coming as same sense. So I'll take theta 1 as 90, then I should take theta 2 as 53 or minus 53.
Minus 53.
So this is the answer. Mu naught I by 4 pi d. D is L sine 37 into sine 90 plus sine of minus 53. ये आंसर है भाई. ढंग से समझ आया तो. Now tell me what is the direction? Direction of field at point B. Direction bolo. Current is going like this. I'll again I have to turn on my video, otherwise you can't see me. No, you can't see me. Current is going like this. Point P is here. So magnetic field is into the plane or out of the plane? Tell me.
Out of the plane.
Out of the plane. So direction is out of the plane. Got it?
Yes, sir.
Any doubts in this, bachcho? Any doubts in this, bachcho? Bachcho, any doubts in this? You please ask me if you have any.
No, sir, all clear.
Okay. So now think on one question which I'm giving as homework, which is not very tough, very lallu simple question if you understand the concepts, but you have to see both magnitude and direction. That's why ये थोड़ा सा कहाँ है वो क्वेश्चन. बहुत टाइम पास क्वेश्चन इनफैक्ट. I don't know, my screen is lagging today, which generally never happens. Sorry for that. Yeah, this is one square loop.
So you stopped sharing.
हाँ पता है. Now I think things will go right. Yeah, this is one square loop. All right. Mm, I am asking you to find magnetic field at 2 points on it. The length of the square loop is 6a. This length is also 6a. This is point P somewhere here. This distance is 2a and this distance is 3a. I need to find magnetic field at this point. And current in the loop is like this. I current is flowing. I need to find magnetic field at one more point, Q, which is a distance of 3a from here. Yes or no? अबे हाँ ना तो बोलो.
Yes.
Now, before doing this question or before understanding this question, I'll tell you one more thing. Suppose this is our current carrying wire. This is I current. And if I am taking any point on the axis of the wire, suppose I am taking point P here, what will be magnetic field at this point? What will be magnetic field at that point on the axis of the wire? Tell me, bachcho, what will be magnetic field on the axis of the wire?
Zero.
Zero. How it is zero? Let us understand. तुम्हें अच्छा लगेगा. If I take any element on the wire, this element is dl bar, whose direction is upwards, and the position vector of the point with respect to this is r bar, like this. Now in Biot-Savart's law, what does formula says? Mu naught I by 4 pi into dl bar cross r bar. What is angle between dl bar and r bar in this case? Angle is how much? Angle between dl bar and r bar is how much? Tell me. What is angle between dl bar and r bar in this case, bachcho? Tell me.
Sir,
Yes, sir. Tell me, what is the dl bar? What is angle between dl bar and r bar in this case?
zero.
Angle between dl bar and r bar. 0 or 180? Stupid.
180.
My God.
180. Whatever. It can be 0, it can be 180, but what is the cross product then? 0. Abbe
Zero.
sine 180 sine 0 is 0 only, no? So magnetic field at this point on the axis of any current carrying wire is 0. Got it?
Yes, sir.
Now will you guys try it out for next class? This homework question. Can you find magnetic field at point P and Q?
Yes, sir.
Yes, sir.
Can you find angles? Can you check whether they are in same sense or in opposite sense? Now, how it is different from previous square question?
Sir.
There, in previous square question, I was able to directly multiply with 4 because the point was symmetric with respect to all the wires. But यहाँ पे I need to individually calculate. That's it. Nothing special. बोलो बेटा, समझ आया?
Yes,
Sir.
sir.
Then again
Sir.
for point Q, the point Q is outside. Again, you have to check the directions of field. One field will be additive, one field will be opposing the other. You have to write the net field. So basically what you have to do is, you need to find field due to each wire on point P and also the direction. If the direction is same, you can add them. If direction is opposite, you can subtract them. Similarly on Q, find field due to each wire. If the direction is same, add them. If the direction is opposite, subtract them. One question, first you tell me. What is field due to this wire on point Q? The highlighted wire.
0.
जीरो. तो बाकी तीन का निकालो और कर लो, उसमें कोई खास बात नहीं है. हाँ ना, तो बोलो.
Sir.
This I am giving as homework question. We'll continue on this from the next class.
Okay.
All right?
So
बोलो
when
भाई.
is next class?
Next week, one day.
Okay, sir.
Chalo.
Thank you, sir.
If
Thank
you
you.
understood everything, you guys can leave the meeting.
Thank you, sir.
Thank you, sir.
So
Huh?
for the wire where the current is going downwards, you'll get some weird values of sine. How will you write that? Like you'll have to put sine of sine inverse of something.
You need not find the value of. Suppose you are getting the answer as see, man. Which why you are talking about? Tell me.
The one where the current is going downwards.
At point P or point Q?
PP.
P. This is 3A. This is 2A. Correct or not?
Yes, sir.
With respect to this wire, you are asking. Correct.
Yes.
So mu naught I by 4 pi d. D is 2A.
Doing.
Yes or no?
Yes, sir.
Into sine theta 1 plus sine theta 2 I have to do. This is our perpendicular distance.
Yes, sir.
Yeah. This is theta 1 and this is theta 2. First of all, theta 1 and theta 2 are taken in same sense or opposite sense?
Opposite.
So what is sine theta 1 from this case? What is this length? 3A. So for this right angle triangle which I am shading, sine theta 1
Sine
is
inverse.
3A by under root of 3A ka square plus 2A ka square. Yes or no?
Yes, sir.
So you can substitute sine theta 1. Similarly, what is sine theta 2? Now can you do it?
Oh, yes, sir. Yes, sir.
Ah,
Okay, okay. Thank you, sir.
chalo.
Yes, sir.
Okay, guys.